is inherent to what we're doing. And I'll explain that in a few minutes when I go through the slide deck. But I wanted to introduce myself. I'm Cynthia Marcello. I have a doctorate in information systems, and I've been working in IT for over 25 years. I'm currently an academic. I teach at the college level, both graduate and undergraduate courses. I owned a business for over 20 years in IT. I was basically a consultant. So programmer, web developer, network designer, network, basically building it from the ground up, cabling, setting up servers, setting up all the hardware, and so on and so forth. I was also SQL DBA for a while, e-business project manager. So, and I also am very heavily into robotics. So I love gadgets and gear, and I'm a nerd. So
likewise. I probably would have worked for you or reported to you when you were.
Go. Yeah. We would have had a blast, right? So it sounds like you're very inquisitive, and I'm that same type of person, right?
Right.
There's so many things we could learn, and there's only so many hours in a day. But I think it's important to expand your skill set. So I've been working in data analytics and data science for about 7 years now, formally, but informally, as a consultant, I was working with data. It was very ubiquitous. But of course, as the internet has taken off and big data has, come about, and so on and so forth, these formal data science, data analytics jobs are becoming more frequently sought after by businesses, right? So, and since I love data and I love looking at patterns of information, that's one of the reasons I got interested into data. So I would venture to guess that you would find this interesting because data tells a story and data empowers you, whether you're focused on data that's in a server log, right? And you're looking for patterns in that server log, and you're looking to maybe look at it from a forensic point of view. Data is data. And even if you're looking at, binary, it's still data. So it's really important. It serves a purpose. So what I want to do, and feel free to interrupt if you have questions as I'm talking, because, you might forget that question, and I don't want that to happen. So we're going to talk about what data analytics is tonight, why it's needed, what are some of the career opportunities, what the course, and actually the boot camp is a series of courses, what it covers, and who's a good fit for data analytics career. All right.
I guess before you begin, what are the prerequisites for taking this course in terms of skills or knowledge?
Okay. As far as skills go, you need to be able to solve problems, or at least have a general idea as how to solve problems. Okay. You should have some math background, only because you're going to be approaching things from a mathematical or computational point of view. But when I say math background, I don't want you to get scared. If you have an algebraic, relational algebra background, stats, maybe you're not so comfortable with stats, I'm going to break down some of those skills for you. So I don't want you to be dissuaded if math and stats are not your thing. Okay. You need to be detail oriented. So for example, you're going to want to pay attention to notes, not afraid to ask questions, and not afraid to explore. I think that's something that's super important. And that's pretty much it. That's pretty much it. It's not a high level skill set that you need to have. I assume that everyone's coming in at the same level. And if you do come in a little more confident or competent in certain areas, that's okay. That'll give you some room to explore further. And I think that's a good thing. Okay. Does that answer your question?
Partly. I guess what I'm still trying to understand is this more of a developer, I guess like a DBA related? Do I need to have any kind of intermediate or even in beginner knowledge of SQL?
Nope, not at all. Not at all. What I will be doing is I will be showing, you're going to be learning some programming languages, which I'm going to go into on the different slides. and it'll break it down, but you don't have to have any SQL background. I will give you all the information you need and all of the syntax that you need, right? And of course, show you where to execute that information. So I wouldn't worry about that because there's syntax for SQL, there's syntax for R, there's syntax for Python. So you are going to be learning some programming, all right? And that's the whole purpose of the boot camp, is to introduce you to that. So there's no assumed foundation that you have to come in with a set of skills already. It's really designed for people. You could have just Excel experience and you're fine in this boot camp. Okay.
What about okay, so what about I work also with things like I'm trying to learn Splunk. I don't know if you've heard of Splunk.
Yeah.
And a lot of that is they have their own markup language, but then there's also a lot of work I've done in the past, but I really would love to be able to master managing or washing data through Excel and using formulas in Excel, like VLOOKUP, XLOOKUP. You know, we dump a lot of stuff in and we do lookup tables, and but I'm nowhere near proficient as I'd like to be.
Absolutely. So one of the things we start off with in the beginning is we do data analytics in Excel. And so basically what we do are some solver exercises. We do some lookup table exercises, and we look at a variety of different ways of manipulating data and learning from the data in Excel to make everyone comfortable. So some of the first exercises you're going to do are those very types of formulas. All right.
Yeah. So, I forget what they call it in Excel, though. There's a feature that came along with Excel. Was it Office 365? I forget what it was called. Power BI.
Power BI, and actually that integrates. Power BI will integrate with Excel. Power BI is separate, and when we get to the visualization part of the course, we will go into Power BI, and we will also go into Tableau. So we'll compare and contrast between Power BI, Tableau, Excel, and also using our markup language to generate different types of visualizations, and we'll do data dashboards in Shiny. So there's a whole array of visualizations. Those are all examples of visualization tools. So I will be taking you through that in the visualization section. Does that make sense?
Yes.
Awesome. Awesome, awesome, awesome. All right, so can you see this welcome slide, hopefully?
Yes, I can.
Awesome. Okay, so I'm going to go through this information, and if I go too quick, just don't hesitate to stop me and ask questions. This is great because this way, you know, if it's a question that's on your mind, you can get it answered, and it gives us, you know, the ability to dialogue. So a data analyst is someone who basically takes data to give insights to the organization. Basically, what story does the data tell? That's what a data analyst does. Primarily, if you're in data analytics and you're not a data scientist, you're going to be focusing on single sources of data. So if the organization has a bunch of spreadsheets or they have a local database that they're working with, it's basically one organization and their data. A data scientist, on the other hand, will pull data from multiple locations, okay? So when we're talking data analytics, there's a variety of different flavors. I'm going to talk about the top four. One is descriptive, and basically descriptive is simply using the data that we gathered over time in the past and determine what happened or what's happening now. So it's basically looking at that historical data and trying to figure out what went wrong, what went right, those types of things. Whereas diagnostic uses the same historical data, but they add the why in there. So we determine what happened, but then we drill down a little bit deeper and we ask why. And that's where we start to look at variables and relationships between those variables. Predictive uses historical data. Again, a lot of historical data, but we attempt to forecast the future, possible different scenario outcomes based on statistical models and machine learning. So we use predictive models like logistic regression, random forest, and things like that. I'm going to show you how to do all those things. And it might sound scary right now, but it's not as scary as you would think. It's very logical. And I'm going to give you a lot of really great code samples to work with. And then, of course, prescriptive, like it sounds, we're going to use that same data, but we're going to make a recommendation. So based on everything that we've learned, what are we recommending for the next step in course of action for that organization, right? Because obviously, if we're looking to gain insights, we're going to action based on what we learned, the knowledge we acquired, and we're going to, with some assurance, statistical assurance, say that we prescribe that you do X because our predictions say that there's a high likelihood of a positive outcome, right? Does that make sense?
Yes.
Okay.
So it's in a way, is there any relationship to, it's almost like I wouldn't say it's a forensic, providing like a forensic analysis?
There are parallels between this and a forensic analysis, absolutely. Okay. And so you could use these skills for the purpose of forensics, right? So for example, right now without getting political, you know, there's a whole bunch of forensic testing based on the machines, the voting machines, and they're gathering data from those machines, okay? And they're attempting to apply these skills to that data, saying, look at the data, you know, that came in and determine what happened, what is currently happening, predict what might happen in the future, and so on and so forth. So absolutely, it can be done in a forensic manner. When you add in forensics, then you have to think about the chain of evidence, right? You have to think about all those forensic principles as well. So you could literally combine forensics and data analytics and data science. And actually, that being said, when you talk about career opportunities, you can think about other industries out there and the fact that every industry that's out there needs a data analyst on their team, okay? So you can take any industry that's out there, retail, manufacturing, healthcare, criminal justice or law enforcement, what have you, and you can then intersect that with data and what the data needs are, okay? Data analysts, the beauty of being a data analyst is that you need less training than a data scientist. And 85% of, this is a prediction according to the World Economic Forum, 85% of companies by 2022 will have adopted some type of big data and analytics technology solution, and 96% of companies will seek to hire new permanent staff. The key here is that it's less costly for them to bring on data analysts than it is to bring in scientists. So there is a prediction that the industry and the economy is going to better support the data analyst getting a job, okay? Now, the skills that are needed for this as a career, which you're going to be learning all these skills. So these skills that are listed here are not to get into the boot camp, but in the field, right, are math and statistics, pattern recognition. You want to be organized, have communication skills, Excel and SQL, Python, R, Tableau, Power BI. That's a nice set of skills that they're going to be looking, you know, to the candidates that they're looking to hire. Okay.
I'm with you so far.
Yep. Awesome.
And I've dipped my toe into each of these during the course of my career.
Excellent. And you know what? So this is perfect for you because you at least recognize what the names are, you recognize what these things are. So the goal is to allow you to then take your skills up to that next level and to make you comfortable. All right. It's really about learning and makes it fun. So the topics covered in the course are basically, there's 6 courses in the boot camp. All right. And they're designed to be taken in a linear fashion, hence the 1 through 6, right? So it is a very intensive hands-on experience for each of these courses, all right? It happens over a 6-month period, and the goal is that you're going to build your project portfolio on GitHub so that you'll actually have your resume ready to go on GitHub with all of your code and all the projects that you've developed, okay? Those will serve as projects that you can point to when you're approaching an employer either for a raise, a promotion, to, get a new job or what have you, you can actually provide your GitHub link and say, here's my portfolio, here's my resume on GitHub. Okay. So basically the first course is data sourcing, feature engineering, and pre-processing. So, getting access to the data, determining what the data has, what features, what does it offer, what variables, and what pre-processing, what cleaning do we need to do to make that data able to be analyzed. All right. So it's a very important part of the process. It might not be the most exciting part of the process, but it's necessary. As you probably know, garbage in, garbage out. If you don't do that first step, what's going to happen. It's going to be downhill from there. The second course, we go deeper into the data and we explore the data and start looking for different patterns at the outset. We're kind of becoming one with our data. We're going to have a data dictionary. We're going to look at the variables, the nature of the variables, and start itemizing to determine which features need to be changed, which features might lend themselves to further exploration based on the problem that we're trying to solve. So we're really exploring the data that we have, and we're applying code in a variety of ways to explore the data further.
Right. To massage the data, basically.
Massage the data, exactly. Exactly.
Do you mean to change slides, or are you still on the slide 1?
I'm on the 5th slide.
I'm only seeing slide 1.
Oh, okay. It says slide sharing is paused. Huh, let me resume. Is that better?
Yes.
Yeah, you went from 1 to 5 at this point, so I'm curious.
Okay, and I'm so sorry.
Take us back to 2.
Let me jump back. Thank you for letting me know. So you remember this one?
I didn't even know. What is the second one? Does the second one have any information on it?
The second one is the agenda.
Oh, okay, good.
I apologize. I must have paused it by mistake. Oh my goodness. Okay. So this is basically our agenda. And then we went into the different types of data analytics and what a data analyst is. All right. And we then went into career opportunities and talked a little bit about, that all industries need data analysts, why they would be more prone to, go for a data analyst. It's more affordable. You're also it's easier for you to acquire the skills, but you're also more likely to get the job as a data analyst. And then down the road, if you want to go to data scientist, now you get that big raise. So it's a win-win for everybody. And then this is where we landed. So I apologize. I have 2 screens and I must have somehow paused the PowerPoint. So I apologize. So questions about course 1, you kind of got that idea that we're sourcing the data, getting the data ready, massaging it, if you will. Course 2, we're digging deeper into the data to see, does this data set have the information we need to gain insight based on our goals for the business problem that we're trying to solve. All right. So we're kind of beating up the data and saying, are you going to be able to tell that story, or do we need to think about other data to bring in to merge it, and so we have a complete story. The third course, we're going to be doing Python, and Python is a programming language. We're going to be using Python, and by the way, there's no cost for the software that you're going to be using. Everything is free or open source. Yay. Okay. So we're going to use Python, and we're going to focus on Python in comparison to R. Not that one is better than the other. If you're a purist, you might say, I prefer Python and I don't do R. My goal is to expose you to both, because when we combine them in course 5, you're going to be like, oh my God, this is so cool, right? Long story short, you have to have skills in both Python and R to really make it in the industry. So that's why I'm introducing you to both, okay? So in course 3, it's really about learning Python, learning the syntax of Python, learning the idiosyncrasies of Python, because all programming languages have their quirks, but also learning some really efficient, quick tips. And that's setting up your keyboard so that you can use shortcuts. You're not having to type full-blown snippets of code. You can actually streamline your process, which is very useful. So I'll give you some really good tips. When we get into R, we're going to be, again, comparing R to Python, learning R syntax, learning about packages in both of them, okay, all the libraries that we have to use, and pretty much applying, taking our business problem to the next step, okay? Then we get to course 5 and we combine Python and R. And we do that right in R. We can actually bring Python directly into R using specific libraries. I'm going to show you how to do that. If time allows, I'll also show you how to use a third-party software, Anaconda, to do this, all right? So there's a lot of different ways to combine Python and R. The reason we do that is R has some additional things that Python does not. So for example, if I'm going to do R markup allows me to take my code and actually crank out documents like PDFs with all my information in there. So you can build manuals, you can build maps, you can build textbooks, you can build tech guides, you can build a whole host of things in Python and R when you blend the two together, all right? You can also create data dashboards, and data dashboards are done in Shiny, and I'm going to show you how to do that. That's done combining Python and R and then adding the Shiny library. So you can take all of that analytics and push it to a dashboard, point to the same SQL database and drill through that data to see different scenarios. So you can compare and contrast, which is very, very helpful. Again, you write code once, you port it many places, right? Very smart and efficient workflow. You wouldn't want to have to recreate your code. You want to just extend your code to the dashboard, right? So that's, I'm going to show you how to do. And then the last course is data visualization. And that's where we get into different ways of dashboarding, different ways of telling the story in Excel, Power BI, Tableau, Shiny, our Markdown. There's a whole bunch of different ways, and we're going to compare and contrast. You know, data visualization, really it's about telling the story. So it's based on the audience. You know, your audience may have a preference. For example, I worked a couple of weeks ago, I ended up on a project where they said everything has to be Tableau. We don't do anything but Tableau. So if I said to them, well, I don't do Tableau, well, they would have said, I'm sorry, but you need to move on, you know? So that was their preference. And it was because all of their clients use Tableau. So they're not going to forsake their clients, right? They're going to give what their clients want. So my goal is to expose you to all these different tools so that you could say, yeah, I'm familiar, I could do that, and apply those fundamentals. Because the worst thing that could happen is a boss or a client saying, we have to have it like this, you know, we have to have it in Power BI, or, you know, given all the things that we know about this project, it's got to go this way. You might even have clients say, you know what, I can't do anything but Excel. So would we want to serve those clients? Absolutely. So I'm going to show you how to build dashboards in Excel, and snazzy ones, nice looking dashboards. All right. Responsive ones. So that's the goal. So those are the 6 courses. You typically are going to be doing about 26 to 28 weeks, depending on how it fleshes out. 3-hour lecture per week and 4 to 6 hours work on quizzes and ongoing assignments or projects that we're working on. So the whole idea is the lecture is going to introduce you to the concepts, go through some of the principles, and then you're going to apply those to the projects that we're working on for that week. Okay. And then of course the quizzes are just to test your knowledge to see, do I remember this? So that's a really important component. Questions on this one?
Yeah, I understand that this is, I would assume this is the reason why you've laid out this course structure with these, you know, these languages and tools. Mm-hmm. In my environment, there's, you know, I'm more on the PC and workspace and desktop mm-hmm. support side, and we're more of an Azure, PowerShell, SQL, and SRSS shop.
Yep, which is fine. SSRS is an extension of SQL Server, which is fine. So, SQL Server reporting services is just a way of providing visualizations to people, right? So if you're using Azure, then that becomes your database. So you can literally point to Azure from Power BI. You can actually use Microsoft's machine learning tools to drag and drop and build a workflow for machine learning purposes. So just like you could use these things to point to Amazon and use SageMaker to implement their machine learning algorithms. So the principles, right? So there's so many different tools out there that you could use, right? If you think of Azure, that's my database in the cloud, right? It's a data source. Can I point to it? Yes. Okay, I'm going to pull my data from Azure and pull it into Python or R, or pull it into my data visualization tools. So you could actually use those tools as a framework for getting the data, sourcing that data, right? And then when you're done building your machine learning algorithm, you can actually send it to the cloud, send that model to the cloud. So anyone with the URL could hit it and actually analyze their data. So from a deployment point of view, you could use Azure and you can use all those different tools to do that, right? So does that help does that make sense?
It does. I'm just trying to figure out right now in my current position where, like right now, I'm heavily invested in trying to learn Splunk and PowerShell, and I work with a data analyst who deals a lot with gathering a lot of that data that we're getting from running these scripts on PCs. So we have situations where we're running scripts. We're literally involved in machine health.
Yep.
And if a set of machines, for whatever reason, the disk performance is a problem, or a set of, a branch has a set of machines where they're not responding to wake on LAN. And we're gathering all of that information and proactively sweeping the environment, pulling all this information into from the machines, as well as Splunk, and then spitting out reports using SRSS. And then in near real time, if we see an outage of any kind, we alert support services before a user tries to complain about something. So we're trying to pick up trends in the data, and we build dashboards in Splunk that pull in all these metrics. And if we see a dip or a warning or an error, we try to get ahead of an outage.
Right. So what I hear you saying is that you have access to some really valuable sources of information, right? Wouldn't it be cool to be able to predict the future outages, right? Wouldn't it be cool to be able to, with some certainty, say, we're going to schedule X amount of resources, whether it's human beings to be, to have certain tiers of tech support. We're going to predict that we're going to have a need based on our, analyzing the data that we've learned from the historical data, right? And you have to remember that there's a bunch of variables that are going to be in that data that allow you to say, okay, these are the things that we know about the environment. Can we look at correlations between this and that, X and Y, right? And then with some certainty, be able to predict the future with those variables, right? So you could use these tools against the data that you have, right? What I would recommend is learning the skills for applying the workflows that these tools provide, and then you can pull the data in and work on those patterns that you're looking to identify, right? So here's the thing: if we go back to this prior slide, right, you would be able to describe what's happened and what's happening now, right? Determine why it happened, okay? Predict the future outcomes, and then make a prescription about a course of action. So this is all problem driven, right? So you mentioned wake on LAN, right? That's a classic problem, it's either working or it's not working, right? So that's a classic problem. There may be factors leading up to either a wake on LAN success or fail. So if we look at the logs, if we're getting data from the system, we can look at a pattern of behavior that system's exhibiting, and then make predictions that if we see an association between variables, we can say, we see a reasonable association between variables and it's statistically significant. Therefore, we can, applying certain machine learning algorithms, predict that this could happen in the future if we don't have some type of intervention, right?
Yeah, our situation is we're pulling information from the environment.
Right.
And as I stated, for whatever reason, a process is overloading on a branch office, or like I said, machines aren't responding to a wake on land.
Right.
And we're using it more as, I don't know, I guess I'm trying to, I guess it will be more prescriptive what we're doing.
It would be prescriptive, but you have to be able to analyze the data to prescribe an action, right?
Right. No, we don't know why something happened. The only thing we can do is report something before the user knows what's happening.
That's
and
right.
Then we send out the support teams to investigate, and then they tell us, the internet service provider was down in that area. That's why your machines weren't responding. So that's unfortunately beyond our scope, because we can't mine any kind of data outside the firewalls of our organization. So you're dealing with branch and satellite offices, and if a server in a data center goes down, then we have a little bit more insight into that. But because we're dealing with point-to-point connectivity between a branch office and campus infrastructure, that's where we only have so much ability to understand what's happening.
Right. I guess based on what you're describing, I'd be interested in finding out patterns. And it's not until you bring all that data together that you're able to look at the patterns. The other thing I was going to mention is machine state. So if you're able to get at the state of the machine in-house, if it involves machines in-house, you can actually look at patterns of behavior on a state level on the machines, okay? So based on that, you can then analyze that data to take it through this workflow. So, and then you can determine, why it's happening, and then make predictions for future outcomes. And then, of course, say, we're going to recommend a course of action, and we believe that it'll address those issues.
Right.
All right. So I'm going to do just a quick description of the course and the learning outcomes. So the first course is the data sourcing feature engineering. And so you're going to learn how to perform a data quality assessment, clean the data in preparation for, data analytics, identify different statistical data types that are ideal for different algorithms. And then, of course, learn about feature engineering, feature aggregation, and sampling, so that we can improve the efficiency of the analysis. Every feature, think of a feature as a variable, right? And every variable has a certain data type associated with it, but it also lends itself to being able to tell that piece of the story that you're interested in. And so by looking at them aggregated together, there's a combination effect, right? And by taking them apart, you can then see the individual effect. And again, this is very applicable for a lot of different areas, right? The exploratory, we're basically looking at, given what we know about the data, what model are we going to build? So you're going to learn about the three main rules of data analysis and use that to inform the model that you select for the analysis. You're also going to learn how to, run through the different statistical analysis that you choose based on, the data that's in front of you, and interpret the results, which is super important. That's where we get into the more math stuff. But we take it step by step, so not to scare anybody away. We'll assume nobody knows anything, and we're going in and walking through it sort of in layman's terms. And then the last one is how to determine what variables align with the research questions. So go back to, what is it we're trying to know? What is we're trying to learn? What insight are we looking for? The research questions that we're posing is, based on that quest for information, and making sure that, hey, the data that we have is actually capable of addressing those questions, right? The Python course, and do you have any questions about that?
No, actually, I was trying to learn Python in order to gain knowledge, to try to become. I had to do like a crash course in Python in order to prepare myself for an interview. And this was for Palo Alto Networks at the time. But unfortunately, it was more network intensive. This was as a sales engineer. But unfortunately, I didn't, I didn't have the practical experience beyond what I was just trying to crash learn.
Yeah. Yeah. And you know what? That's where having these projects that you work on, that builds that practical experience, because you start to see, hey, this problem is just like the other one I did. And you start to see similarities. So it's just like anything in technology, whether you walk on site into a network and you're like, okay, classic client server environment. What do we have? Tell me what you got, and then you can make inferences based on what you saw with other similar types of environments, keeping in mind that there's variability based on, the individual factors that come into play. This is the same thing. So you're able to, see the parallels by going from project to project, and building on that skill set. So, like I said, it's very similar to your approach that you've taken, already with technology in general, right?
Yeah, I don't have a formal education.
Which is fine.
In IT. I literally majored in my college. I was a history sociology major.
Excellent.
And
no, and that's fine. Believe it or not, all of my tech knowledge that I gained was not from the college degrees that I got.
Right. I had to learn as I went, from simple hardware repair to get into the business. Yep. Getting like Novell NetWare certified. Yep. And then from there, literally every day was school.
Yep. No, I've been there. I know exactly what you're talking about. So these are the things that, people come from all different backgrounds, and it's perfectly okay. The key here is that you're able to learn these things, and there's a high likelihood that schools are not going to teach you these skills.
Right. And companies don't want to invest in hiring people unless they've learned something from somewhere else, so that they can, attain the benefits of
Absolutely.
Unless you work for a small shop that's willing to teach, have you learn on the job, and will, have a learning curve.
Yeah, and that's a very good point. So, I think this would really set you up well to be able to get through an interview. There's actually some great resources. There's some classic things that they're going to want you to know, and I'm going to expose you to all of those things. The big thing then becomes your GitHub profile. And they're going to ask, what kind of projects have you worked on? And they're going to say, don't even show me the Titanic example, because I don't want to see it. Everyone's done the Titanic example. They've grabbed it from Kaggle, and that becomes their thing. These are going to be projects that I've designed, and it's based on projects that I did in my business, setting up my business back from the 90s. So these are all case examples, this retail shop that I worked with, a small Department of Defense one that I worked on. There's some case studies that I built for Microsoft that, hey, that would be a great one to go over. So these are all different case problems that I've developed over the years. And so they're going to be very unique, and they're going to have those special twists to them. All right. So it's going to help you stand out. The big thing is developing your resume on GitHub and creating a place where you can, so it's kind of like a business card. You're just passing it out to people. So that's important. Having it out on GitHub is one thing. You can also import data from GitHub as well. So you could actually have a repository out there for your own projects, either real projects or projects that you brag about. These are projects I worked on. So I'm going to show you how to do that. So Python, like I said, is different than R. We're going to approach different size data sets. Now, right now, I'm working on a COVID-19 data set from Mexico. that has, it's actually grown to about 2.5 million records, okay? That's something that, you can bring into Python very easily. You can bring it into R very easily. You can bring it into Excel, but Excel is going to be a little bit slower. So we're going to compare and contrast. What does it mean when I'm working with different data sets? Is it better to choose one tool over the other? So
yeah, I'm very interested in becoming getting more advanced knowledge and learning more about how to do this in Excel.
Yeah, absolutely. And here's the thing. I'm working with that data set in Excel, and I'm making it work. There's a method to the madness, and I'm going to walk you through that workflow. You got to remember that if you're working with CSV files, there's a high likelihood that you may need to work in Excel to start, and that's perfectly okay. You might want to do simple filters in Excel, and you don't want to worry about scripting things. So why not use Excel? It lends itself. So there's a variety of libraries in the Python IDE that we're going to work with, and also create a workflow to perform analytics in Python. The same follows with R. So R is just another programming language. Again, it's important to know R. You can also build packages in R. I'm going to show you how to work with packages in R that already exist, that we pull in from CRAN. These are open source, but down the road, you might decide to build your own packages. So if you have a very unique workflow in your organization or your business, you can actually write a package that serves your needs. So let's say you do financial things and you want a special package that does all the data and analytics the way you want it. You can build your own. So that's where the power comes in. Again, taking through R, the IDE, and how to build a workflow for R. I'm going to show you how to do that. Then we combine the two together, and it's so cool because now we get into the R Markdown, which I talked about earlier, as a communications tool, and also an interactive web-based dashboard using Shiny. So we're going to take all those things, import data sets from different repositories, crank it out as we can do it as a PDF, we can do it as a different type of document, or go to Shiny and make it fully interactive and allow us to drill down using a dashboard. A lot of fun. So building a notebook actually in our Markdown. And then the last is the data visualization. So that's, now that you have everything, you've analyzed your data, you need to tell the story, and it's based on your audience and what works best for them. So how to use Excel, Tableau, RStudio, Power BI, all these different tools lend themselves to telling the story. Some do it a little bit differently, but you're able to pull data from all these different repositories of data that we have into these tools and tell that story. So we're going to spend some time doing data visualization and basically communicating what we've learned, the insight that we've gained, and then telling the stakeholders, this is what we know. Keeping in mind that all stakeholders are different. So if you're speaking to the medical community, there's going to be certain things that they're looking for in their visualizations. If you're dealing with the local government officials, they might want something, right? So every stakeholder group has their own preferences and lingo and what have you. So learning what is going to resonate with them and communicate it, the story effectively, is super, super important. So it's really a teaching tool so that you can show them what their data is trying to tell them. All right. So that's the last slide in my deck. So I'm going to stop sharing that. Questions on that?